There is an animal alive today that was already here when the dinosaurs went extinct, 240 million years. That is how long this animal has been operating. For context, the entire human lineage, from the first Homo sapiens to right now, covers roughly 300,000 years. The saltwater crocodile predates us by a factor of 800. In 240 million years, its core design has barely changed. Nature found what it was looking for and stopped looking. This is what it became. The saltwater crocodile's confirmed range runs from northern Australia through the Indonesian archipelago, across the Malay Peninsula, into parts of India and Sri Lanka. That is roughly 10,000 kilometers of viable coastal and river habitat. It is the largest living reptile on Earth. Males exceed 17 feet in length, over 2,000 pounds. A 17-foot saltwater crocodile stretched out is longer than a vehicle. It outweighs a compact car. The largest confirmed specimen on record was a male captured in the Philippines in 2011. His name was Lolong. He measured 20 feet and 2 inches and weighed 2,370 pounds. He was not an anomaly. Unconfirmed reports from river systems in Papua New Guinea and parts of Borneo place animals larger than Lolong in territories that have never been properly surveyed. Those animals have not been measured. No one has gotten close enough. And that is where the scale question starts to get uncomfortable. Start with the armor. Running beneath the skin along the crocodile's back is a layer of bony plates called osteoderms. They are embedded bone growing directly into the dermal tissue, and they cover the animal's dorsal surface in overlapping rows, dense enough that small caliber rounds have been documented deflecting off them without penetrating. That is not their primary function. Osteoderms generate microcurrents in the water as the animal moves, and those currents cancel the surface disturbance that movement would otherwise produce. The result is that a 20-foot, 2,000-pound animal can close distance in water with no visible ripple at the surface. Now add the pressure receptors. Integumentary sensory organs, ISOs, are distributed across the jaw and snout in dense clusters. They detect pressure changes and vibration in the water at a sensitivity level that allows the animal to track moving prey in complete darkness. It does not need to see you. The bite force measures 3,700 pounds per square inch. That is the highest recorded bite force of any living animal. A lion registers around 650 pounds per square inch. A great white shark, approximately 625. The saltwater crocodile generates nearly 6 times that figure in a single strike. Once the bite lands, the animal rolls. The death roll uses full body weight to tear tissue rather than crush it, which means muscle resistance becomes structurally irrelevant within the first rotation. But physical design is only part of what makes this animal what it is. The behavior is the other part. Documented crocodile attacks in the Indo-Pacific region go back centuries, running through colonial records from India, Australia, and the Philippines. One of the most referenced events took place on Ramri Island, Burma, in February 1945. British forces drove a Japanese battalion of roughly 1,000 soldiers into a coastal mangrove swamp during an engagement. Fewer than 20 soldiers emerged. Historians continue to debate exact casualty figures. The surviving accounts agree on what they heard through the night. More recently, behavioral researchers studying saltwater crocodilians in controlled environments documented something that sits outside a standard predator profile. One animal at a Queensland facility spent approximately 6 months adjusting its behavior near a specific keeper. It had an established routine of advancing toward a barrier and stopping at a fixed point. Over months, it began stopping fractionally short of that point. The keeper, observing the new stopping position, shifted his approach over time. When a new keeper rotated in and stood at a slightly different position, the animal noted the change on day 1. On day 2, it observed from the water. On day 3, it charged the new position at full speed. The keeper was not harmed. The physical barrier held, but the behavioral record was explicit. The animal watched the same pattern for months, learned where the weakness was, and waited for the right moment to attack. And that raises a question about what else this animal is capable of. The saltwater crocodile is documented in open ocean hundreds of kilometers from any coastline, not disoriented or carried by current, navigating. One tracked individual was relocated 126 kilometers from its home territory by researchers, transported by boat to rule out land travel. Within 20 days, the animal had returned, having traveled more than 400 kilometers around a coastal peninsula. It went home. The mechanism it uses to navigate across open water is not fully understood. What is documented is the outcome. Displacement does not work. The saltwater crocodile exhibits what biologists call negligible senescence. Its organs do not degrade on the timeline that governs most vertebrate species. Cellular maintenance continues at a rate that does not produce the standard markers of aging. Confirmed captive specimens have lived past 100 years with no significant physical decline. It can go 2 years without eating by reducing metabolic output to a near minimum while remaining fully capable of an explosive strike when prey comes within range. Salt glands on the tongue allow it to excrete sodium and regulate osmotic balance, meaning the animal can operate without physiological adjustment in freshwater rivers, coastal estuaries, and open saltwater ocean. It has been found in trees, up to 30 feet above the ground. There is no single environment within the entire Indo-Pacific range where this animal cannot function. The ecosystems this animal favors are the same ecosystems that are hardest for humans to move through and nearly impossible to monitor continuously. Mangrove deltas, tidal river mouths, coastal estuaries where water visibility drops to centimeters below the surface. Sustained research presence in these areas is rare and seasonal. Cooperative hunting has been observed in several of these environments. Larger individuals drive fish concentrations towards shallow shorelines. Smaller individuals hold position at the edge and intercept. Researchers still debate whether this was planned teamwork or just individual animals taking the same opportunity. The truth is, scientists still don't have enough data about saltwater crocodiles at the limits of what they may be capable of. Remote populations in the Indonesian archipelago, Papua New Guinea, and parts of northern Australia exist in areas with no sustained scientific presence. What is documented represents the cases where a human was close enough to observe and survive to report it. Everything beyond that boundary is a gap, not an answer.